Alright, let's talk about 2D arrays and functions. Actually, there's not much to talk about at all because 2D arrays work exactly like one-dimensional arrays when it comes down to functions. Let's do this through an example. So let's write a couple of functions and we're going to call these functions from a setup. So the first function is populate array. Populate array receives the size of a 2D array and an integer value. It will then construct a 2D array of integers, and it's supposed to be n by n, so number of columns and rows are the same. So you're receiving the size of the matrix and also an integer value. It will construct a 2D array of integers with the received size and initializes all elements of the array to the received value. This function returns. So when we say returns, you need to actually return the array. So we're going to send the array back up of integers back to the calling function. Then we have a function called print array. This function receives a 2D array of integers as argument and prints its content to the screen in a string in a matrix format. So let's program this. So what I would advise you to do is pause the video and actually program these two functions and have a setup function that calls these two functions. And I'm going to do the same. So if you do pause the video, it'll be great because you can compare your program with my program. So let's go ahead with function populate array. So we're going to have populate array. It's going to receive a size. It's also going to receive a value that you're going to initialize everything by. What is the return value of this function? The return value, it says that it's going to return a 2D array of integers. So the return value simply is going to be a 2D array of integers. That's the return type. No semicolons there. So that's what we have for populate array. Let me just have my void setup function as well. So we're going to call this function from here. So we have a size. So let's make a 2D matrix with that size. So we're going to say int mat, as in matrix, equal new int and size, and then we need to initialize this entire array to value. So the only way to do that is to visit every cell and initialize it to value. So the way we would do that, we would say int I equals 0, I less than, we can just say size I plus plus. And then we have int j equals 0. J less than size, because don't forget number of columns and number of rows are the same. J plus plus. So the outer loop is to go. It goes through rows, and the inner loop for each row goes through all the columns. That's the This is the outer, so bit of a review for with loops, and this one is of course the inner loop. All right, now we're visiting every cell, so basically we need to say mat I and j equal value, which is what we are receiving in this function. And then at the very end, we're going to say return. We're going to say return mat. So the way you would do a function here, you would, for example, say int my array, which is a 2D array, and this 2D array is going to equal, is going to receive what populate array returns. And what I could do is I could, for example, say I could pass the size as 4. Actually, let's define a couple of variables. So I'm just going to say int my size as 4, and I'm going to say int val as 10, and I'm going to send my size, and I'm going to send val. So this function is going to construct and populate a 2D array, which we call mat, based on the size it has given us and based on the value it has given us, and we're going to return mat to set up, and mat, the content of mat is going to be copied in my array. And then in order to print this, we had a function print that's going to receive a 2D array of integers, and it's just going to print it. So in order to write a function, so it's just going to print, right? So what was the function called again? It was called print array. So let me just say print array. Print array is going to receive a 2D matrix. So it's going to receive a 2D matrix. So I'm just going to call my matrix, let's say this time I could call it mat again, so it really doesn't matter, so I can call it, let's just call it mat. The return type is just going to print everything to the screen. So what is it sending back to the calling function? Nothing. So the return type is actually void. So then, in order to print, we just need 2 loops again, because we have to go through each cell. So we can say for int I equals 0, I is less than mat.length, because we don't actually, no variable size has been passed, it's just getting mat. And then I plus plus, so that's the inner loop. For the outer, that's the outer loop. For the inner loop, we have int j equals 0, mat. So for each row, we don't really have to do this for we're getting the length of each row, so the number of columns in each row. We don't necessarily have to do this here, simply because it's a n by n matrix, but I'll just did that anyways, and then j plus plus. And here we're basically saying when you went to each cell, print it. So print mat row I column j. Gonna print the space. And simply this is going to print out the columns. And here we're going to print a new line. So after each row is printed, we're going to go to a new line. So after printing all the columns in each row, go to a new line. All right. That's about it, unless I've made a mistake somewhere. So we need to call for our function print array. And how do we call that? Well, the return type is void, so we don't actually return anything. So we can just call it, we can just say print array, and we're going to pass our array to be printed. So let's run this. So this program is going to call my array. It's going to call populate array, and which is going to construct an array which is going to be copied into my array, and then it's going to print the content of my array. So let's run this. There's an error. Okay, I have one too many braces. Let's run this. Oh, another mistake. Int j equals 0, mat dot length. What is going on? Cannot convert. Oh, sorry, I'm missing my condition. I do apologize. So j less than. All right, and it's working. It's a 4x4 matrix. If I go up here, you can assign this to a random function if you wanted to. If I go up here and make the let's make the size 8, then obviously it's gonna be an 8x8 matrix. Let's draw the memory diagram of this program to get a good understanding of how everything is working. I'm going to change this back to 4 so that it's easier to draw. All right. So we're going to start our memory diagram with the setup function. So in setup, we have size, which is set to 4, and we have val, which is 10. Then we have my array. So my array is a dot in memory. It simply doesn't exist. And then line 3, we are going to go ahead and call populate array. So populate array. So this is populate array, and we are passing size. So size is being sent by value, so 4 is just copied. Actually, I do apologize, this variable is called my size down here. So this is my size. So this is copied into here. So size is 4, and then we also have value. The value of val is copied into value, so we get 10 over here. So the control of the program is with populate array. The control, so we are out of setup. The computer sees the scope of populate array. We have mat, and we're going to declare mat to be a 4x4 matrix, or the 2D array, which is the same thing. So essentially, we're going to have rows. So rows are 0, 1, 2, and 3. And up here, we have columns, which are labeled 0, 1, 2, and 3. So through this loop, we're going to visit every cell. So this should be clear for everybody. And we're going to initialize everything to value. So this whole thing is going to be filled with tens. So sorry, just want to make sure that it's clear for everybody. Then we're going to say return mat. When we say return mat, this mat, so it's not as efficient, right? This mat is going to be taken from here and it's going to be copied in here. So my array is going to be exact replica of the top, and this is going to be filled with tens. So it's basically copying, just like you copy a file from one folder to another folder. This is exactly what's happening. So it's returning an array by value. So you can imagine if this array was, let's say, 100 by 100 or 1000 by 1000, it would take a long time for it to copy. So sending arrays by value back is not always the most efficient thing to do, but sometimes we have no choice. So then when we say return, this function populate array completely dies and goes away, right? So I am just gonna delete it so I can have room. So it's done, and that's what we end up with. And then we're gonna call the other function print array. So let's get print array in there. So we're going to have print array. To print array, we're going to pass my array, of course, by reference. So I have my array is the only function argument, and as we said, this is sent by reference, so it's just a link. And as a link, we can use it to index through. So the way we use it is just like an array. Nothing has changed. We're going to use this to print. So we're not copying this over anymore, but with the link, we are able to use my. Oh, sorry. My bad. It's just a small correction. So we are going to pass my array, which is this. We're going to do a link, and inside of print, inside of print array, this is actually not called my array anymore. This is called mat. So mat has a link to my array. So if you say mat I, and if you said mat 0 and 0 inside print array, this would actually be talking about this element, because this is index 0, 1, 2, 3, and then 0, 1, 2, and 3. So 0, 0, it's talking about that. If you said mat 0 and 1, then we're talking about this guy, right? So there is a link between mat to my array, and you can use mat just as you would use my array in order to go through the array. So hopefully that's making perfect sense to everyone. I do want to give you just a last thought. I do want to give you an alternate solution to populate array. So instead of, I said that when you copy an array, it's a little bit inefficient. So instead of doing this, we could have done this way. So for example, we could have said my array, and we could have initialized our array to be size and size. To this, so for that problem, that's what we had to do, because populate array, the description said that it's supposed to create an array. But we could make a function that we create the array up here, and then we can simply just pass. We can do this. We can simply pass the array. Okay. We pass the array by value, so we have to change here, and we're going to, I'm just going to call this mat. So, which means that we're not going to create mat in here. I'm going to take this out. And we're not going to have a return value. So it's going to be void. So I went a little bit fast in this last part, but I believe you guys are keeping up. You should be able to keep up basically. So the populate array is now passed by value. So we're going to create our array here. We're going to send it down here, and we're going to populate it. So we're not gonna do that whole copying the array from here back to top. So this is a lot more performance, a lot more better in terms of performance. So if I just draw the memory diagram for this, let me just take I'm just gonna do undo. So that means that first of all, this means that we have my array, and we declare my array inside setup. So my array is actually declared 4 by 4, and it's filled with zeros because it's allocated using the new operator. Then when we create populate array, this is populate, we're going to have mat and value. Value is going to contain 10, and mat is going to link to array. So we're going to use mat, and we're going to go to all the cells. So we're basically going to make this into a 10, 10, 10, 10. Then we go here, 10, 10, 10, 10. We're going to update all the values because we're populating. And then we're done. We don't need to say return anymore. There is no copying anymore. And we just say done, and this thing disappears, and this link is no longer. So we end up with something like this. So 2 solutions and the same output, and hopefully it's clear for everybody. The second solution, we didn't have to copy everything over. We just accomplish everything with a link. So it's pretty smart. All right, thank you.